Today we're going to begin AP Calculus Unit 3. Unit 3 is on differentiation of composite, implicit, and inverse functions. The very first thing we're going to cover is the chain rule. So this section is 3.1, the chain rule, and I'm going to cover this rule over 3 or 4 lessons because there's so many applications to it and so many ways that it can be presented. I'm going to try to break it down. Today we're going to be doing just the very basic chain rule. Once you get this down, then we'll continue with some other chain rule examples and types of problems. So basically you need to understand that the notations for derivatives that I'm going to use in the next couple of sections, if they say find y prime, then your function would have been set equal to y at the beginning, and then y prime is just the derivative of that function. If your function is f of x equals, then the derivative is f prime of x. And sometimes they'll use find dy over dx instead of saying y prime. They all three mean exactly the same thing. And we learned in previous units that derivatives have several meanings. They are the slope of the tangent line, they represent rates of change, there are a whole bunch of different applications. So all of those things will still apply, but now we have a new operation to use to find some derivatives on some more complicated functions. And the chain rule does simplify things. At first it may seem a little bit confusing, but it does simplify your life quite a bit. And the chain rule, I think, is just a really good tool to use because it saves you a lot of time. So the directions are going to say use the chain rule to find y prime, f prime of x, or dy over dx. And when we're going to use the chain rule, when we have a function within a function within a function is a composite function. You've done f of x and g of x, so find f of g of x or g of f of x. That's a composite function when you put a function within a function. And so to take the derivative of a function within a function, we're going to use the chain rule. We learned back in Unit 2 how to take the derivative of a simple function like this. Y equals x to the fourth. To take the derivative of that, or to find y prime, we said we take this coefficient, we multiply the exponent times the coefficient, which would be 4, and we decrease the power of the exponent by 1. So the derivative of x to the fourth is 4 times x cubed. Now we're going to use this knowledge to help us do something that's a function within a function. And I'm just going to make up a new function. I'm going to say my function is 3x squared to the 5th power. Okay, now if I'm using the chain rule on this, basically how we can think about this is my function and it's within this function. And what I can do is something called U substitution. U substitution is a common way to explain things to make it simpler, and then we get to the point where we don't need to use U substitution anymore. So if I make this U substitution, what I'm going to do is I'm going to let U equal the inside function, because this is a function within this whole function. So the inside function is the 3x squared. So I'm going to let 3x squared be my u, and then everywhere I have a 3x squared, I'm going to replace it with u. So if I do that, I have y equals u to the 5th. Here's how the chain rule makes this a little bit different. When something we didn't learn when we did this is when you do the 4 times 1 is 4 and decrease that power by 1, if you take the derivative of this part, the derivative of the x, wouldn't that just be 1? So technically what we've got here is multiplying that by a 1. It's not there because multiplying something by 1 doesn't change its value. So we've just never had to do that before. But now that u represents something else, not only are we going to have to define u, but we also have to define du. And du is the derivative of u. So the derivative of u here is 6x. So when I take the derivative of this and find y prime, what I have to do is take the 5, multiply it by 1, so that's 5u to the 4th, and then I have to multiply that by du. So if I do that and I get my final answer, y prime is equal to 5 times u is 3x squared. My u is to the 4th power, and my du was 6x. And that's the chain rule. So basically what I'm doing here is I'm taking the derivative of this part. I'm just pretending like this is just an x value. Well, if that were x, wouldn't I say that's 5x to the fourth, which is what I have right here. And then I have to take the derivative of the inside part to finish out the problem. The derivative of the inside part is 6x, and so I just tag that on the end. So when we're using the chain rule, we take the derivative of the outside part times the derivative of the inside part. So I have a few more examples here, and we're going to do these just like we did that one, except now I'm going to try to do this without u substitution. I know that my u part is this stuff inside the parentheses. So that is my inside function. So I'm going to just kind of pretend that this is x, and that what I have here is x to the fourth. Well, if that's x to the fourth, then my y prime is 4 times the x, which is all that mess inside. I decrease the power by 1, so that's to the third. And then to finish this off, I have to take the derivative of the inside part. So the inside derivative is 6x plus 2. Now, if I could simplify that, I would. But a lot of times with your applications with derivatives, they're going to want it in factored form anyway. So we normally just leave it like this. There's really no need to go further until we know what they want us to do with this function. So I would leave it like that. I would never try to FOIL this out. That would take way too long. You could multiply by the 4, but still, if you're trying to find like horizontal tangent lines or something like that, you're going to set it equal to 0 anyway, so you're going to want it in factored form. So at this point, we're going to leave it like this. That's our final answer. Let's do one more here. We've got y equals -3. This time we've got a -3 in front of our x part to the third. So we could kind of imagine that as being y equals -3x to the third. Well, how would I do that? Well, that would be -9x squared. So we're going to do that here, but we're not going to use u substitution. We're just going to treat this part right here like it's our x. So this is our x, so we've got -3x cubed. Well, if that was -3x cubed, I would take the 3 times -3 is -9. I keep the x part, and I decrease this power by 1, so that's squared. Then to finish off the problem, I have to take the derivative of the inside part. The derivative of the inside part is 4x plus 7. And we're finished with that chain rule. Looking at this one, this is a -1 times our x part cubed, or we could say times our u part cubed. To take the derivative, y prime would be 3 times -1 is -3. We keep this part the same, decrease the power by 1, and then to finish it, we take the derivative of the inside part. So that's 6x plus 4. And that's the chain rule for this one. Now, we could use the quotient rule here, but I think it's easier to rewrite this problem and then use the chain rule, because if you think about it, isn't all of this stuff on the bottom just to a -1 power? So if we do that, y is equal to, first we're going to rewrite 2 times 3x squared minus 10 to the -1st. Then we're going to use the chain rule. To use the chain rule, we do -1 times 2. So y prime is -2, because -1 times 2 is -2. We keep the inside part, 3x squared minus 10. Decrease that power by 1, so that's -2. Take the derivative of the inside part, which is 6x. Then to rewrite that answer, we could change it back to a fraction. So we have the -2 times 6x on top, so that's -12x, over the 3x squared minus 10 squared. And if you think about that, if we were to have done the quotient rule here, wouldn't we have ended up with the 3x squared minus 10 on the bottom squared? So you could do it with the quotient rule to check yourself, but I think you're going to find that anytime we can convert it to the chain rule, it is going to make it a little bit easier for us. Here's another one that requires a rewrite. If we rewrite that, we have y equals, the 5 is on the outside, And then this part can be written as a fraction exponent that is negative. This is understood to be 3x squared minus 2x minus 4 to the 2/3, but we're going to move it to the top as a negative 2/3. So for that one, we've got 5 times 3x squared minus 2x minus 4 to the negative 2/3. Negative 2/3 because it was on the denominator. We're moving it to the top. So then if we use the chain rule here, we've got y prime equals negative 2/3 times 5 is negative 10/3 times the inside part, which is 3x squared minus 2x minus 4. Decrease that power by 1, so that would be a negative 5/3. And then we take the derivative of the inside part, which would be 6x minus 2. And then I'm just going to do a quick rewrite with that. Well, I've got a negative 10/3, so that negative 10 is going to be on the top. The 3 will be on the bottom. The 6x minus 2 has a positive 1 exponent, so that's going to be on top. And then the minus 5/3 is going to go back to the bottom. So we've got 3x squared minus 2x minus 4 to the positive 5/3. And I can just leave it like that. You could convert that to the cube root of 3x squared minus 2x minus 4 to the 5th. I would just leave it like this. It's simpler, it's less work. It would be an easier process if you leave it like this, if there's an application that goes along with this problem. So now it's your turn to practice. I've got a couple problems here. Take the time to copy them down, do them on your own, pause the video, and then I'll come back and show you the answers in a few minutes. Okay, here are the answers. So with this one, there is no rewrite necessary. We can take the 4/5 times 5, which is 4. We keep the inside part here, decrease that power by 1 to make it a negative 1/5. And then we take the derivative of the inside part, 6x minus 4. And then we rewrite this. Anything with a negative exponent needs to be put on the bottom. And so on top we have a 4 times 6x minus 4 all over 3x squared minus 4x minus 2 to the 1/5. You could distribute it here if you wanted to, but there's no need. Don't do any extra work unless you have to. First, I did a rewrite. I rewrote it as negative x squared plus 9x minus 7 to the negative 1/2. Then I do the chain rule. So negative 1/2 times 1 is negative 1/2. Times the inside part, decrease that power by 1 is negative 3/2. And then we take the derivative of the inside, which is negative 2x plus 9. Then I just simplify it a little bit. The negative 1/2, the negative 1 is on top. The negative 2x plus 9 is on top. And on the bottom, the negative x squared plus 9x minus 7 to the positive 3/2. And here, I could distribute that negative sign to make it a little bit simpler. So that would be a positive 2x minus 9. I would suggest that you do that, but I like to show you why that is, so that if I were to just show you the answer, you might get confused as to where that came from. So I wanted to make sure I explained that to you a little bit better.